The next thing we're going to do is to analyse the PV panel output against tilting angle there, and also load. Now, the first thing we need to do before we start that is to align our panel so it's pointing north. See, I've got the compass set up here, so we're pointing north. I've aligned our unit with this, our test unit with this, and I've got a protractor so we can make further adjustments to its angle. So we have the experiment that we're going to do, which is measuring photovoltaic response with panel inclination. Now, on the back of this experiment, you'll find a typical panel output from a manufacturer's panel, and you see we have our current, our I, versus our V, and these are the typical values we would obtain from a panel such as the one where we'll be doing the experiment on. So we're going to now go through and explain how we will take those measurements and actually take the measurements. When we take the measurements, we will fill in the table shown on the second page of the experiment. That's panel voltage with respect to inclination and load current. What we're going to do generally is to adjust the panel to different tilt angles like this, and at the same time we're going to adjust the load. You can see the load current increasing here, and measure our voltage on the other meter. So we'll do this in a number of steps, and for each step we'll take those calculations, those readings. So we had this set up for the experiment. From the output for our panel here, we go to our load. It's our electronic load here. We come out of the load here through our ammeter, and we're measuring the voltage over here on this meter here. We will measure this voltage and current for every inclination of panel. See, we've got our protractor set up here so we can incline the panel to various degrees, and for each degree of inclination we're going to also adjust the current, which we'll do with our electronic load down here. And you can see if the panel held at one value here, our current on our left-hand meter here is changing, and I can decrease that back to minimum at that point. So with the setup now, so it's receiving light on the panel, if I adjust the load here, we'll see the current will increase. Okay, so the current is increasing there. Our voltage will remain fairly steady until we reach the curve of the characteristic. If I remove the current altogether, remove the load, my voltage will increase. I'll have an open circuit. But once I put the load on, my voltage will once again be limited because of the characteristic. With respect to the shot that's just been taken outside on our deck in the sun, you will have noticed that we did a number of things. One thing was, first of all, we lined up our panel setup so we had it facing at the optimum angle for the sun. So we had our north up here, and our unit now has to sort of go this way, so it's 40 degrees away from north. We then rotated the panel through set degree angles. First of all, we went for the optimum angle. In this case, our angle was 60 degrees. That's actually from the vertical, so it's actually 30 degrees from the horizontal. So we actually had a panel set at 30 degrees, and that was our first setting that we actually took. Then we moved the panel down 10 degrees and took our whole range of values there, a whole range of current load values at that angle. We then moved down another 10 degrees and took a whole range of load current angles at that setting as well. And by taking these settings at each angle, we were then able to produce the IV curves similar to those that you would see from the manufacturer.